Okay guys, so here is the answer key to the guided practice for quarterly and monthly compounding. You probably noticed that there's a duplication of three situations, with the exception of the bottom three are monthly compounding and the top three are quarterly compounding, but everything else is equal. Same amount of initial investment, same annual interest rate, same number of years invested. So it's good to compare these individually. So I've set up everything for 2, 3, 5, and 6, but I'm going to go through 1 and 4 from scratch. So number 1, we have $1,000 invested at 5% for 10 years, quarterly compounding. Important thing is to make sure you know what kind of compounding you're dealing with. So quarterly compounding. So if we're compounding, we have to take the $1,000, the initial investment, the initial principal, and multiply it by 1 plus something. We need it to grow. If you don't have to divide the annual interest rate by anything because you're dealing with annual compounding, then you can just add the annual interest rate, 5%. If you need to divide the annual interest rate by something because it compounds more frequently than once per year, then you do that first. So 5% is 0.05. That gets divided by 4 with quarterly compounding. And now for the repeated multiplication, and that's where the exponent comes in. So how often is that going to happen? How many times is that going to happen in 10 years that your money grows? Well, it's going to grow 4 times per year with quarterly compounding, and it's going to grow for 10 years. So your exponent needs to be 4 times 10, or 40. Okay, I've already done this out on a calculator, and it comes out to $1,643.61. All right, let's contrast that with the same situation, but monthly compounding. So $1,000 invested, 5% for 10 years, except this time your money grows monthly instead of quarterly. We should end up ahead. Let's find out. We're going to take that $1,000. We're going to once again grow it, so 1 plus something. It's the interest rate, the annual interest rate divided by the number of times it compounds in a year. This time it's 12 times per year with monthly. However, it's going to grow more often. It's going to grow 12 times per year for 10 years. So the exponent is 12 times 10. That's 120 growth periods. And that comes out to $1,647 even. So you can see how that compares to quarterly compounding. It's about $4 better. So not a big deal in terms of, a small amount of money, $1,000 invested at a smaller interest rate, 5%. But let's step it up. Number 2 says let's take $5,000, 5 times more money, higher interest rate of 7%, and let it grow for twice as long. And I've already done this calculation for you. It turns out that is $20,031.95. Not bad. How does that compare with quarterly compounding in the same situation? $5,000 invested at 7% for 20 years, but let's do monthly compounding rather. Well, hopefully you got this, but now it's $20,195.69. And now you can see, we're up to about $164 better. So the improvement improves. Let's try one more comparison here. A $50,000 investment. Now we're getting into some real money. One time at 10% return, very good return, for 25 years. You're letting it ride for the long term. And if you did this, didn't touch it, didn't even put any more in, you'd end up with $590,000. Oops. $590,685.81. pretty nice return on the investment. However, only difference being the compounding period, quarterly versus monthly. If we did the same thing with our $50,000 at 10% for 25 years, with monthly compounding, we'd end up with $602,847.25. And that is a difference of over $12,000 with nothing different other than the frequency of the compounding. Pretty cool. So that's how we set up those problems. I would recommend that you write the formula out every time to get in the habit of what's the mathematics going on here. How does this work? Why are these numbers where they go? The math really tells the story of why we divide the APR and why we multiply the exponent. All right, hope you enjoyed. Take care. See you next time.